day, guys. Okay, I want to talk about conservation of momentum, and I'm planning to do it, or at least in this video I want to do it by looking at the simulation or a simulation. Okay, so conservation of momentum actually says that momentum is conserved. Well, when we talk about momentum being conserved, we have to have had some changes, and that change is provided by a collision. Okay, so if you look at the screen right now, you can see two cars, a red car and a blue car, right? And then you can set their initial velocity, right? And at the same time you can set their masses, and the reason for that is simply because momentum is affected by two variables. Number one, the masses of the body colliding, or the body that is moving, and its velocity. So this is the initial state, right? This is the initial state before the collision. So let's just write that down. We have initial total momentum, which is the momentum of the red car plus the momentum of the blue car. Okay, so let's have that, and then we can calculate that, which is mr vr plus mb vb. Okay, and that is, so the red car is 3 kilograms, the velocity is 3 meters per second, plus the blue car is 1 kilogram and its initial velocity is -2, right? And that gives us a value of 6 minus 2, so that is 4 kilograms per meter per second. So that is the initial momentum, right? So let's make it collide, right? Let's make it collide, and then we can see the final velocities. Okay, it's going to collide. There we go. Okay, so now we can calculate the final momentum, total momentum. Again, we have mr vr plus mb vb. All right, so now our red car is still 3 kilograms, but it's moving at 0.5 meters per second, whereas our blue car is still 1 kilogram, but it is moving at 5.5 meters per second. Okay, all right, so and you can see that the red car is actually moving in the opposite direction. So we will have there a negative sign. So that is -1.5 plus 5.5, which is 4 kilograms meter per second. Okay, so this is our final momentum. Okay, so if we compare those two values, the first one, this one, and the second one here, what we find is that our PI is actually equals to our PF. Okay, and this is in fact, so if we simplify it further, we can say that PF minus PI is equals to 0, which is also equals to the change of momentum. Okay, so the conservation of momentum says that momentum is conserved, that there is no change in momentum, right, in a closed system. Because what we mean by closed is that these two cars are not interacting with anything. It doesn't interact with another car, it doesn't interact with the walls, it only interacts, the collision only happens between those two bodies. Okay, so momentum is conserved in a closed system. So by looking at this simulation, right, this simulation, and then calculating the before and after situation, what we are able to do is to show that, oh, okay, momentum is conserved, which is right, let me mark it down, which is the statement right over here. This is what the conservation of momentum says. All right, that is all. Okay, thank you very much. In the next video, right, I will be talking about types of collision: elastic, inelastic, as well as explosion. All right, so I'll see you in the next video. Thank you very much.